Good evening, class. This is Mrs. Albright, and tonight we are working on Module 3, Lesson number 4. And our objective this evening is to represent patterns when multiplying by 10, 100, and 1000 in both arrays and numerically. So make sure you have a whiteboard or a piece of scratch paper, and let's get started. Here we've got a place value chart to help us solve this problem, and the problem is 3 ones times 10. So I can start by making my 3 number discs. Here's my 3 ones. And when I multiply it by 10, what we've already learned, multiplying it by 10 moves it over here into the tens column. So my 3 ones times 10 becomes 3 tens, or we can rewrite that as 30. Now, what happens when we take those same 3 ones? And first, we're going to multiply it by 10. So now it becomes 30. What happens if we multiply that by 10 again? What does it become now? 3 ones times 10 becomes 300. Well, what we can do is take those 3 ones, and when we multiply it by 100, we are moving it 2 places over on the place value chart. And we can see that 100 is really 10 times 10. And that's why, since 100 is 10 times 10, we can just hop over 2 places on the place value chart, times 10 times 10. If we take those same 3 ones and we multiply it by 10, it becomes 3 tens. If we multiply it by 10 again, it becomes 3 hundreds. And then what happens when we multiply it by 10 a third time? It becomes 3 thousands. So when we multiply a single number like 3, and when we multiply it by 1,000, that's the same thing as saying times 10 times 10 times 10. So since 1,000 we have those 3 zeros, we can hop over 3 places on the place value chart. So let's take a number like 15, which is 1 10 and 5 ones. In order to multiply a number like 15 by 10, we need to multiply each place value column separately. So I'm going to take that 110 and multiply that by 10. That becomes 100. And I'm going to take those 5 ones and multiply that by 10. And that becomes 5 tens. So really, it's the same thing as saying 15 times 1 times 10. We can decompose that 10 as 1 times 10. So this becomes 105 tens. In this problem, we have 22 times 100. So I'm going to take my 2 tens, 2 ones, there I've modeled my number 22, and I'm multiplying it by 100. Well, what we learned at the beginning of this lesson is that if we are multiplying by 100, we can hop 2 places over on the place value chart. I would come here for times 10, here for times 10 more. That is my times 100. And those 2 tens become 2 thousands. And then I'm going to do the same thing with my ones. Times 10 times 10, there's my times 100. And those 2 ones become 2 hundreds. So my answer for 22 times 100 is 2,200. So I really just kept the 22 and added those 2 zeros since I was multiplying it by 100. Here we're starting with 4. And now we're multiplying this number by 20. Now what I want to do is decompose this. I'm going to take my 20 and decompose it so it's 2 times 10. If I stretch out this multiplication sentence, 4 times 20 would be the same thing as 4 times 2 times 10. So my 4 ones times 20, I'm going to take my 4 ones and I'm going to multiply it by 2 first. So now it becomes 8 ones. Then I'm going to take all 8 of these ones and multiply it by 10. And that becomes 80. We can also decompose them. Look at this by looking at it numerically. Group that 4 and 2 together. 4 times 2 is 8. And then 8 times 10 gives us the 80. For this last problem, I have 6 times 400. The first thing I want to do is decompose this 400 to 4 times 100. And then I can rewrite this multiplication sentence as 6 times 4 times 100. So now to continue this problem, I'm going to use my place value chart and I can multiply the 6 times 4. I'm going to start with my 6 ones and I'm going to multiply that by 4. So I have 4 groups of 6 ones. Now I need to do some bundling because I can't leave 24 in my ones column. So I'm going to take 10 of those ones and that becomes 110. I'm going to take 10 more of those ones and that becomes 110. And now I am left with 4 ones. So my 6 times 4, when I'm representing this over here numerically, becomes 24. Now I have to take that 24 and multiply it by 100. So I'm going to take these 2 10s and I'm going to multiply it by 10 by 10. So I'm hopping over 2 places on the place value chart. And those 2 10s become 2 thousands. And now I'm going to take these 4 ones that were left and I'm going to multiply that times 10 or times 100, and that becomes 4 hundreds. So 24 times 10 becomes 2,400. So really when you're working with these problems such as 6 times 400, you're taking the first number of your 100 value, the 4, multiply it as 6 times 4, get that answer of 24, and then add those 2 zeros because then you're just multiplying it by 100 and we've already learned how to do that. So this lesson was really for you to see it broken down and why that trick of just adding the zeros work. If we're multiplying by 10, we add 1 zero. If we're multiplying by 100, we add 2 zeros. But make sure you are multiplying your whole numbers first. For this last sample problem, we are only going to solve it numerically. We have 5 times 3,000. I'm going to decompose my 3,000 as 3 times 1,000. So I can rewrite my number sentence. 5 times 3 times 1,000. If I multiply my 5 times 3 first, I know that that is 15. Then I am multiplying 15 by 1,000. 15 times 1 is 15, and then I add those 3 zeros to make it times 1,000. So these questions, I want you to think about what would be in these missing blanks. So here for problem A, what number times 8 would equal 800? For B, 3 times what number would equal 3,000? C, 8,000 times what number, or 8,000 is equal to what number times 1,000? And 1,000 times 4 is equal to what? And here are your final problems. 2 times 80, 2 times 400, 5 times 5,000, and 7 times 6,000. Please do the best you can. Bring any questions you have back to class where we will continue working on this skill. Have a great night. I'll see you tomorrow morning.